All right, 47. Determine the intervals of the domain over which the function is continuous. And we've been looking now at continuity for several questions. So we know that to be continuous means that we can graph the function without having to lift up our pen or pencil from the paper. And so here we have some sort of function that's been given to us, and the point -3, +2 that's been identified as a closed circle. So that means that this point, -3, 2, is included. It is part of the graph. This graph exists at this point. And so if it exists at this point, we'll set our pencil down onto the paper, and then we'll start graphing. All right, and we'll assume that that graph goes on and on forever without stopping. And because we were able to graph this part of our function without having to lift up our pen or pencil, it means that this function is continuous over its entire domain, over the entirety of its domain. And if this graph does go on forever, we know that as the graph heads out to the right here, the x value is getting larger, heading out towards positive infinity. But because the graph, we'll say, starts here at this point, right, -3, 2, the x value is -3. So the domain over which this function is continuous is from -3. And notice that I'm using a bracket here because we were told that at the point here, -3, 2, this was a closed circle, right? So that tells us that we are including this value of x as being part of the domain. If this was an open circle here, then we would have to say, all right, we're not including that x value as being part of the domain, so we would use a set of parentheses. But because it was a closed circle, we're saying, yes, -3 is part of the domain. Make sure you include it when you're indicating that in your interval notation. So we go from -3 out towards positive infinity, and we know that we use parentheses with infinity, and so we can say that the domain interval over which this function is continuous is from -3, including -3, out towards positive infinity.